So I would like to welcome everyone to our Architects Focus presentation, Retrofit Solutions and Design Opportunities for the New York City Townhouse. I would like to give a special thanks to Hvac Ingui Architects for presenting today, but also for your support of New York Passivhaus throughout the years. It makes events such as today possible, so thanks for your support. We will have Michael Ingui present today, partner at Hvac Ingui Architects, and at May, who is partner at Building Type and is also the Passivhaus consultant on some of the jobs. So welcome, Michael and Ed, and please take it away.
Thanks, Andreas. Hey, everyone, how are you? I'm Michael Ingui from Hvac Ingui Architects. I will share my screen. We're going to focus on some of the retrofits that we've been doing. So again, my name is Michael Ingui. I'm from Hvac Ingui Architects. We're, I think, about a 25 person firm in New York City, where we are doing a lot of types of buildings, both inside the city, outside the city. We've doing a couple of interesting passive houses, one upstate, which is going to be a passive commercial facility with prefab panels, which is fun. We're doing a passive house outside of the city on our ranch house, which we're converting and retrofitting into passive, which is also fun. But we do an awful lot of historic masonry retrofits. And what we've been trying to do over the past 7 or 8 years is really try to figure out a repeatable approach. A lot of the types of projects you can see from the screen are in landmark districts. They're all 1 and 2 family houses. And so the question we continuously ask ourselves is, what can we learn from these clients, the clients that have the budget to do these types of projects, so that clients and other people who might not have the budget can do it and do it in mass. Getting the retrofit right is incredibly important. And I think with today's challenges, just knowing that we have the answers and the passive house community has the answers is just really essential. So yeah, so just some of the types of projects that we do. This is a house in Carroll Gardens where we did an addition at the top. We did an addition at the rear. It's a passive house. It'll be net zero or close to it when we put solar on it eventually. This is another one, really difficult, what should have been a difficult project to do as a passive house in Brooklyn Heights. It's a colonnade house. It really doesn't look very different, except for we restored a lot of the woodwork. These are simulated double hungs. These are passive house casement windows, which match the profile of what was originally there perfectly. The inside had really had a lot of damage to it. So we could do a more modern insertion on the inside. So these are the types of projects we do. One of the things that I like to focus on is how do we get to do them? And I'm not going to focus a lot in this presentation on it, but I'll focus a little bit. We've done, I think, 7 certified houses, a bunch of non-certified, and we have, I think, about 12 or to 14 passive house projects in the office right now, and almost all of them are retrofits. So why does it fit the retrofit building type so well, and how do we get our clients to sign on? And part of it is we ignore everything on the left, and we only mention the things on the right. And we're excited about the money savings. We're excited about saving the planet. We're excited about the air tightness and the balanced ventilation and the high performance windows and the thermal bridge free design, blah, 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 blah. Nobody cares. Absolutely none of my clients are listening to me. They will donate money to whatever I just asked them to donate to, but they just think they're going to get something less. It's guaranteed. It's all they're thinking about is, what am I giving up? Well, if you start to think about it as a win-win, where you're thinking about it as a healthy thing that they're doing for themselves, and you focus on the amenities and describe the exact same things in the left as if it's to the right, you say, listen, if you want have a house that doesn't have too much bugs and dust and so forth and unwanted moisture, and if you want filtered fresh air 24/7 and windows that create a safe, warm environment that have almost no street noise, and then all your walls and floors will be warm, comfortable, and they want those things. I mean, when it comes down to the budget, you say, okay, well, which one of those things do you want to cut? Do you want to have unsealed walls and have some bugs and dust in the house? And nobody says yes. In fact, nobody knew to ask the question. And I think that's the most important thing to just remember. We may know these things, but people didn't know they could have filtered fresh air 24/7. And once they knew they did and they could, they want that. Once they know that, we live in leaky houses, and if I didn't want them to be leaky, I'd create a sealed environment, and I'd put the fresh air in where I wanted it to and have it filtered. Once they knew they could do those things, they want it, but they actually don't come to you knowing to ask the question. So once they know the answer, they can't unlearn it. And so they want it as much as they want the Sub-Zero, as much as they want the designer kitchen. So I think it's really important with how we describe it. Again, we have people coming to us now wanting high performance houses and passive houses, but for the most part, people just want a really nice home. And then the other item is with that out of the way, the other item to really consider, and I think it's something that I haven't spoken about enough, is and we're noticing on our non-passive houses and how we're dragging Ed May and John Mitchell into those projects along with Kramer and some of the others, because we've gotten used to and we've taken for granted the fact that the passive house consultant and bringing them in early, and Ed's going to talk a lot more about that, so I won't, but we're bringing them in at schematic design. And a lot of our houses, even the ones I showed earlier, they've got big expanses of glass, and they've got a dormer, and they've got something that just didn't work the way we thought they would. And I can't quite get the insulation I wanted, or I'm going to have a thermal bridge. And having a passive house consultant in early, or using the passive house planning packages yourself, or whatever program you're using yourself, what it does is it de-risks that issue. We're not guessing. We're not, well, I think I got it. I think we've got enough, or using programs that don't sync with the way you're dealing with your building systems in your envelope. They're really truly de-risking an incredibly important part to us. I'm not wondering at all. I know I missed it here, so I got to make it up there. Or I learned that, no, I'm sorry, I don't care what you got to do. You can't miss it here. So the whole de-risking of design and mechanicals and some of these other items and thermal bridges for architects, I think is a really essential positive. And so we've actually brought them in on non-passive houses because we've gotten used to it. The other item here, which has been kind of an epiphany for me, that actually means that I came up with it, but I'll take credit for it. But anyway, Ed, John, and contractor have been doing it, so I've been brought into it. So is the fact that the contractor can de-risk the whole process for themselves as well. I'm constantly asked, do you have to be a passive house contractor? Or do you have to use a passive house contractor to do a passive house? And I always say no, and they can be trained. And what you're looking at here is something that we do. We do a contractor collective or a whole bunch of other contractors who all compete. 4 of these contractors didn't get the project that they're currently in, and they're still there with the contractor who did get it, and they're comparing notes. And it's really wonderful. But what's also interesting about this project is this was that contractor's first passive house. And not only did he do this project as his first passive house, he did a second one, both technical big projects. What he did was he hired Ed and John as a consultant, the same way we would when we do structural work. And a lot of times our contractors are hiring structural engineers for their means and methods to make sure they get their shoring correct. If the contractor who's doing a passive house can call Ed and John and have them come over as they're taping it for the first time, and as they're putting their window in, and as they're doing other items, and they don't have to go backwards. Well, that de-risks it for them. I mean, think about it from the contractor's perspective. They're excited. They're working with this architect. He's got this cool new thing, this passive house thing. The details look good, and he's taking the course. But like, nothing in their world goes the way they think it's going to go. Nothing's perfect. But having that passive house consultant available, I actually think is a pretty significant game changer to bringing the costs of passive house down. And so I think it's pretty huge. I also think for a passive house consultant, it's an entire other revenue stream. So how does passive house influence our designs? Some of the projects we're going to see allow us to do lots of things like large expanses of glass, huge doors, and windows and other items where I don't have radiators and I don't have piping, and I don't have things that allow me to really get into that. But in terms of the whole design benefit, it's really just working with the Passivhaus consultant earlier and knowing where I could do those. So we're going to use this as basically a case study. And for anybody who's already kind of seen some of the case studies that I've talked about, these are some updated things that we've learned and talked about. And hopefully Kevin Brennan's on, and if he's not, he'll be on later. But some of these came from him as well. So just to talk a little bit about the cellar. We've got our cellar where we have our rigid insulation. We've got, in this case, Stego makes this wrap, the Stego wrap that kind of comes up. We've got our rebar and we've got our concrete slab. You know, we're already going to put a plastic sheet under there. This is a little bit more expensive, not much, but it works better. We're already going to do a lot of these different things. But what you've got here is you can see your air seal on the side walls, which is liquid applied, hitting that. And it just creates this warm, dry, comfortable cellar. And in New York City, we're constantly building down versus going up. We're constantly having to make these cellar spaces something that they were never intended to be, because landmarks especially won't let us go up. Just some more details that I really loved from one of Kevin's most recent installs. So it's Kevin Brennan from Brennan and Brennan Air Sealing, where you can see the wrap coming up. You can see they've got some of the tape where they've made some penetrations. This is the term bar, something that I didn't know actually, and which is how he's been doing it is they'll put this on. They've got it already adhered to the wall even before this. And then what he's doing is he's turning it over so the term bar is hidden and taping it here and sealing it there. So it's actually sealed, which is really great. You're also starting to get to see some of that liquid applied air sealing as you get around the joist, and some of the time spent on that, kind of getting into that party wall that I was just showing, and just some different versions and options of what we've been doing. We've been actually doing a bunch of different things recently, like keeping some of the plaster on instead of taking it all off, especially the plaster that's in a good place. But the thing I would say, and you can kind of see some brick here, Owen Colleen from Clean Construction would say this very often to me, we're going to be the last one to touch these party walls for a long time. So the first thing we have to do is make sure that this plaster is really on. We have to make sure that this brick is really well pointed still. And then we can air seal. We've got to make sure everything's in a good place. But you can start to see you've got the plaster, you've got the liquid applied air seal, little extra attention paid to the joints. We've done this in lots of different ways, where we've even done it with a historic stair, where you've got, this is the original stringer against the wall. We did not want to remove the stair here. This is the liquid applied going into it. We've even used the bottom of the stair for some ERV tubes. Here's the next version of that, where we kept the plaster and then air sealed that as well. It's clean, it works, it's past its blower door quite nicely. And we got to keep a lot of it. On the exterior walls, these are interesting. So we've got the detail here, which goes from the exterior wall into the party wall. And you've got to do a little bit of insulating to make sure that that thermal bridge and that cold does not come through to that point. But the other thing, and Ed maybe could talk a little bit more about this when he talks later, but one of the important pieces of the program and just working with a Passivhaus consultant is making sure we're not over insulating this wall. Sometimes the walls are not in the best shape. Sometimes they're in good shape, but they let a lot of moisture in and so forth. And you've just got to be really clear about letting them dry out and having it be a vapor open assembly. And so here, for example, what you can see is kind of a first liquid applied go on, and you've got some framing members that are off that wall far enough, service cavity, and then sheetrock. Oh, I missed the other layer. Sorry, the air seal layer. Kind of important. This is maybe a better version of that, where you can start to see another key piece, which is that front joist pulled off that front wall just enough to get some insulation in there. Now we've been actually this still showing the ones with the blocking in it. Recently, we've been using the structural grade insulation, so you can just use that without the blocking. And again, you can start to see a service cavity where they can run BX and so forth. This is one of Kevin's most recent projects where he has kind of his smart membrane coming over. So much of this comes down to sequencing. He's left a bit of smart membrane taped up here. He's going to leave this just kind of hanging down, the floppy bits. And that's going to allow them, when they build the interior wall here, they're going to allow them easily to tape onto that and not deal with how to really get in there and how to deal with that. You can start to see how they've brought that around the corner here. And I really paid a lot of attention to that, because once they put the stud up here, you're never going to be able to get to that again. And then what you start to see here is what a lot of people are doing. And this is Kevin who's taking this photo. And this, I think this entire project was Partel. And but it's a smart membrane coming over the windows behind here. We often are using the blower door as our tool during construction, even before the windows go in. So you just run it right across. He cuts it out later. You can start to see some of the batten that's happening in front of that. You can. Happens to be a ceiling picture where you can start to see. This has been. They've already done the dense pack in there where they've blown in the cellulose. For those of you who don't know, so it's densely packed cellulose. So dense pack is kind of the way they describe it. You can kind of see the billowing. Little things that are in this photo that are so interesting to look at. One is the care that was taken where the sprinkler pipes are. You've got plywood that goes from joist to joist and then you've got this attached to that. Same thing with the ERV duct. You can see it here. You can see the tubes right there, where again, joist to joist, and it's attached to it. Simple, clean details. A lot of time spent in the corner just to make sure they got this right, because that corner is really difficult to get to. This, I think we're going to have other photos of this, but this project happens to have shade pockets. One of the things in terms of these windows tilting and turning, dealing with the shading, we've done the shades in the actual window itself, and we've done shade pockets as well. But, and then, this doesn't change very much. I mean, this is a project where we were able to gut everything. This is that project I was showing earlier with the stair where we weren't able to gut everything, where we had this really great plastic crown, where we wanted to keep that crown. The brick had a lot of issues on the outside and the inside. Again, you have to be honest with yourself about this brick. That brick had to be pointed on the outside. You can't just leave the outside and kind of hope it's going to be good. You've got to restore it and really make sure it's a good wall. And so we actually wound up using, you can see the plywood up here. We wound up using the plywood, we ran it between joists. We air sealed all around that. And then we wound up basically using the plastic crown as a little bit of the air seal and air sealing to that. So it's air seal to plastic crown to air seal. And it's only just to show that you can kind of see that a little bit more here. I think this is our Pro Klima product, but on this particular job. So, and then you can start to see it. Now this is a parlor floor, and this is a second floor. This is a simulated double hung, so we didn't need to do a shade pocket here. This is a full casement window where the whole window comes in, so no shade pocket on this one. On other portions of this project, we do have that shade pocket. And sometimes we just do shades or curtains on the inside. Here you can see what this contractor does. This is SMR Contracting. They actually are using masonite and thicker staples because they don't want the staples to pop and they don't want to have to deal with that. So they just had a whole bunch of this masonite just ripped so they can just deal with that. Just little tricks. And as the windows get installed, we start to see some of the things that we're doing. I think this window detail has changed so many times. And even the past couple of months, it's changed, where what we're really trying to do, and I think we've got a good picture of it here. I'm gonna go back to that detail in a second. But what we're really trying to do, Kevin has installed this, and what he's done is he's pre-taped the window so that once it goes into, I'll go back to that in a second. Once it goes into this box, it can slide in. And that tape, you see how the tape is blue taped to the window? He then untapes it and takes the backing off, and then can easily have a nice, clean, perfect install where that window is, and then the whole window gets slid into place, the whole assembly, and then it gets attached to the side. So now I'm going to go backwards a little bit. It doesn't mean you don't have to protect the window opening, or that's going to do everything for you. We're still counter flashing this. We're still making sure our water stays out. You can see Kevin's actually installed this liquid applied to all this. The brick mold winds up covering this, so you don't see it. But this, before all that went in, this counter flashing, to count on sealants and count on caulking is short-sighted. So so coming back to this window detail, you can't really see it here, but this counter flashing that's in there, that points up a little bit, and where you've got the windowsill. But the other thing that you're seeing is you're seeing that plywood box, and you're seeing how you don't really see it here because it's not drawn, but there's another stud right here, and it's not touching the brick, and it gets installed into that. So it's having very little contact with the masonry opening, and we're able to kind of insulate all that. Sometimes we're using rigid, sometimes we're using cellulose, mostly a combination of the two, making sure that's really well sealed. Here's that brick mold that's covering that gap I was describing earlier. So the window install is a toughie. It's one we spend a lot of time kind of trying to perfect for a lot of different reasons. It's got to be quick enough where it's repeatable. And so this process where you've got that pre-taped window, then they tape it to that, they slide it in, seems to be the fastest way to do it. Here's the install. It looks just like a regular window. Here's a picture of some brick that we're repointing and dealing with. We actually stripped the paint off 5 or 6 different layers of paint. We're actually leaving some of it on too. It's not coming off, so we're not going to rip it off. So coming into the roof, you start to see that parapet coming up. Very often these need a lot of work. We're doing a combination of outboard and inboard. Another great reason to have a Passivhaus consultant. If it were up to me, I would have done all outboard, no inboard, and we weren't getting the right place for where the moisture lines would be, and Ed was able to show that to me, and I had to come down to reality and not expose the joists. So there's just different things that we weren't guessing. We were using it as a design tool before I ever told my client I could do those things. So it's really, really helpful to have them involved. Just some interesting detailing. We've had contractors use both plywood and smart membrane. Some of our contractors love plywood. We don't use OSB. We haven't found it to be sealable enough. This is actually AC plywood. Even with the price of plywood, we still have contractors who like to use plywood. They just know it. Other contractors love this. Some using a combo. You're seeing we've got the smart membrane on the front when we've got the plywood up here. The interesting thing about plywood is what you can do is attach hat channel right to it. You can create these boxes for this downlight, for the ERV tubes. I would say our office does everything we can in the universe to not do downlights and not have to do this stuff. Every time you make one of these penetrations, it's just a place for things to go wrong. You can start to see some blown in cellulose going in from Kevin's crew here. Mechanicals, it's an easy conversation, or it's become easy. A lot of mechanical, but not a lot of mechanical. Ducts where I don't want them, no ducts where I don't want them. It's so easy to look at it. And a lot of our houses are now becoming all electric houses, and we've become quite used to it. Heat pump, HVAC, here's our ERV. This happens to be one brand of a heat pump hot water heater. We've used several of them. They all seem to work really well, no complaints. Heat pump dryer, which I have, and I can tell you it looks just like the gas dryer and takes about 20 minutes longer than a typical dryer on a full load. But other than that, you cannot tell the difference. And we're putting these in a lot of our other apartments or other places where we couldn't do venting. They now have lots of different induction ranges. This is one that just came out that looks like an industrial range. So we're using that. We've got a few others, but all electric is becoming much easier to deal with. And I think with the clients, the biggest sell seems to be the range still, but a lot of them get over it pretty quickly. Just a couple of little things mechanically. I think Kevin has mentioned that it'd be great to keep the pipes further apart. This is a nice project and nice job by him, but I think it would have been a lot easier for him to do that. He would have also probably used pre-installed gaskets, but he came in late in this particular case and didn't have those options. So, I mean, I've described a little bit about our project, so hopefully I didn't fly too fast through it. And but I think one of the interesting pieces here is to describe it from the Passivhaus consultants' standpoint and where they come in and why and how. And for me, what's interesting about having Ed on it is you're going to hear kind of a similar journey, but from a completely different perspective. So anyway, with that, here's Ed.
Righty, thanks, Mike. Can everyone hear me okay? Is everybody able to hear me all right?
All right, let's do it.
Fantastic. Thank you, Mike. So thanks Andreas and New York Passivhaus for setting this up and inviting me, and thanks for everybody for being here. So as Michael said, I'm just going to talk a little bit about the process that we go through when we work with Mike and his team on these types of retrofit projects, and from the Passivhaus consultant's perspective. So you know, we have had the opportunity and the good fortune to work with Mike and his team on many retrofit projects, which has been fantastic. And we've learned a lot, and we're sort of happy to share that. And so, as I said, I'm going to talk a little bit about what it is that we're doing as Passivhaus consultants. You know, that's a sort of a new discipline. And so I think it is useful to talk a little bit about what that means and sort of what the steps are and what the tools are that we're using to do the types of work we do when we are working with folks like Mike and his team on these types of projects. Next slide. So the first thing that we do when we launch into a careful analysis of a project like the one that Mike is describing is the whole building energy model. Now, I don't know exactly what you would imagine when I say the words whole building energy model, but it's not that exciting and it's not that sophisticated. There's no magic to it. It's a recording, it's a record, it's a model of all of the bits and pieces of the building, and it's built in a very peculiar and particular way to allow us to execute some certain types of simulations to get an estimate, to get a prediction of how much, let's say, energy, sometimes carbon, sometimes all sorts of different things cost, how many resources and what type of consumption the building is going to see over its lifetime. And so we do a very careful job of trying to record all the bits and pieces, all the parts, all the aspects, all the attributes, all the data of all of the various bits and pieces of the building, and weave them together into a single whole building model. And this model is really the piece that enables us to hopefully make good decisions as we move forward through the design process. We're always referring back to this model once we've built it, as we ask questions, as we try and make decisions, as we try and decide, should we use this insulation here? Should we use that insulation over there? Should we do this much insulation? Should we do that much insulation? Is this a good enough window? Is it not a good enough window? All of these types of decisions are informed by this whole building energy model. So this is a really fundamental piece of the picture. It's a really important tool for us to use as we're evaluating the performance. But that model doesn't exist just as a sort of static piece. As I said, we're using it to evaluate options. So one of the things that we're always doing is we're starting that energy model as early as possible, and then we're using it to test different options. Say, what if we did it this way? What if we did it that way? What if we built it this way? What if we use this material? What if we use that material? What if we use this other product? And then always putting those things in context with one another to say, all right, well, listen, here's the building at, let's say, a code minimum level of performance. And then here's the building if you start to change this, that, or the other. Right? We're always looking for that difference, that change. That's the really important thing. Is this better than that? Those are the types of things that we're always trying to decide as we move through it. So we spend a lot of time, probably as much time, working on these types of analytics as we do building out the actual model itself. And as I said, we're always building the model with an eye towards these types of tests and this type of testing. So this is, again, looking at the whole building as a sort of single performing entity. But of course, we also zoom in quite a bit at the same time. So Mike, if you go to the next slide, please. So while we are looking at the whole building, we're also going to be zooming way in and assessing individual spaces or individual elements for their own performance. So while we're looking at the whole building's energy consumption or energy cost or carbon emissions consumption, we might also be zooming in and looking at individual rooms and assessing, for instance, as we see in the photo, the image here, the thermal comfort impact of the material choices and product specifications inside of that space. What we're seeing here is a detailed simulation of radiant temperature asymmetry, which is one of the important factors around thermal comfort, as a function of surface temperature is being driven by the material selection, by the product selection, in particular the windows in this particular space here. And what we're doing is working with the design team to try and dial in or try and actually design comfort into our buildings, using these types of simulation tools to help inform those types of design decisions around, well, is this the right window or is that the right window? Is this a good enough glazing specification or do we need a different glazing specification? Of course, it's going to be driven by questions around cost and constructability and availability, but equally so, in our opinion, around questions like comfort. Right? Those are really important aspects of the whole. That was, as we were just looking at, that was thermal comfort in winter time. But of course, we are just as concerned in a climate like New York about thermal comfort in summertime. So working on radiation assessment, shading assessment, overheating assessment is just as important, if not more important, in many cases than that wintertime thermal comfort, because of the level of glazing that we often have in a lot of the modern buildings that we work on today. And one of the main things that we're trying to do on that front is improve the shading situation of the building. So one of the things that we're always testing out when we zoom way in is the shading impact and the overheating impact and the comfort impact on the occupants in the building. And one of the main things that we're trying to do is dial in and design good shading packages for our projects here. It's really important in a place like New York, in particular New York City, where we have things like where we suffer from the urban heat island effect and we have very glassy buildings. You know, these types of things are going to be really critical when it comes to the comfort of the occupants. So we're looking at the whole building, we're zooming in, and we're looking at things like thermal comfort in both the wintertime and the summertime. And of course, we're also going to use these types of simulation and analysis tools to dial in things like assembly design, levels of insulation, and type of materials and that we're going to use to build the building. And again, we're never designing, or we're never saying this is the answer, this is the solution, this is the one that you have to use. It's always about assessing a range and trying to identify that place where you're getting the maximum benefit for maybe the minimum cost or the minimum pain in the neck factor, the minimum space. You know, different on every project what you're sort of optimizing for. But it's always about assessing a range of options, right? There's no one way to build a Passivhaus building, and so you're always looking at a various range of R values and performance aspects. But again, we're working closely with the design team to dial in those assemblies and make good decisions, strategic decisions around how we deploy resources like materials and cost. So at the same time that we're sort of keeping all of that in mind, we're looking at the building as a whole system, and we're looking at comfort, and we're looking at details and assemblies. We're often also going to be building up the details of the project. Now, I prefer to work out details in the 3D model. That's just my preference. So I come from a construction background. I sort of think in terms of bits and pieces, putting things together. And so when I'm working out details, it's hard for me to work in 2D plans. It doesn't work for my brain. So the way that we often work out and design details is through little maquettes or little mock-ups or little vignettes like the one you see here. This is a working model. This is the kind of model that we use with folks on Mike's team to pass information back and forth and sort of model together and sort of work out the details. And in particular, a lot of those issues are around things like thermal imaging and air tightness implemented. And we're often just building up the building sort of one piece at a time and trying to think through constructability and sequencing, all of those types of issues when it comes to these types of details. So we're often using lots of different tools at the same time to assess the building in lots of different scales and sort of time periods. So while we're working on those details, one of the other tools that we're often or always going to bring to bear is a specialized set of simulation tools, which allow us to do what we sort of know broadly as thermal bridge assessment. So this is an example of a two-dimensional heat flow analysis of a particular junction detail, a proposed junction detail. Now, for any particular project, you might have dozens or maybe even hundreds of these types of details, but you might move through 5 or 6 or 10 iterations of every detail. So one of the things we've had to do over time is become really fast at exactly this type of simulation. This type of simulation is simulating heat flow, and it's giving us an incredible amount of information about things like overall heat flow, but also surface temperatures. Both of those things are going to be really critical when it comes to the performance of the building. The trick here, though, is that this can't take a week to produce. You can't get a detail from a client and then sit on it for a few days and then take a weekend off and then do the detail and then send it back. By the time you've sent it back, the project is done. They've already built it. So what has to happen is we have to become really fast at this. And so we're using some particular tools that allow us to do that really quickly and hopefully keep up with the design team as they're iterating through and making good decisions around detailing around these types of deployments, which has been challenging to be sure, but you know, sort of important to be able to do that, I think, for the projects to succeed. And as I said, we are always using lots of different mediums and different types. So we're building, you know, whole 3D models, and we're doing thermal bridge assessment and simulation tools. And then when it comes to communication, we're often going back to good old-fashioned hand drawing, especially when it comes to details. I find that to be a really effective mechanism for communicating information. This is just a one example of a particular, it's a weird steel and door and walkable skylight detail all in one. It's a complicated detail, to be sure. But, you know, this is just a snippet of the type of drawing that we use to communicate information with both the design team and the construction team. As we're thinking about, all right, well, let's do this, and then we'll do that, and have this other. And the reality with a lot of these buildings we're working on here in a place like New York is they're really complicated. The details can be really complex, and there's a lot of moving parts. People are trying to do really ambitious things with glazing and walkable skylights and all sorts of things. And as a result, the details can become quite complicated. And so, again, it's all about iterating through to find the right solution for the project. And so you need lots of different tools here also there. Okay. One of the pieces that we work on when we think about representation, we think about how we communicate, is that we want to take into account. We try and take into account questions of time and phasing. You know, a lot of the stuff that we do, a lot of the work that we work on is related to the specifics of construction. Construction is all about sequencing. It's all about, well, first I put this piece in, and then I put that piece in. And so we have to somehow think about that and take that into account when designing these details. Trust me, I've designed plenty of unbuildable thermal bridge free details. The challenge is not really to just build or design thermal bridge free details, but to design thermal bridge free and airtight details that can actually get built in the real world. And so we're always trying to think about, you know, well, first these pieces and then we do these other pieces. And again, it's often about a back and forth with the builder, because we often don't know what the sequencing will be. Oftentimes the sequencing is driven by material procurement issues. Well, I can't get that piece delivered until 3 months from now, but I have to keep moving. So I'm actually going to do this piece next week. Often a back and forth and a more fluid sort of interaction with builders in many cases. And then, of course, we're focusing way in on things like air tightness. You know, that's one of the really critical aspects for us to try and plan and think out. And, you know, we work real hard to try and plan out air tightness on projects ahead of time. There's always, in particular, when it comes to retrofits, there's always pieces that are sort of left unfigured out. You know, there's always surprise situations when it comes to retrofits, but we try as hard as we can to design in all of the air tightness layers in the early stages. In my opinion, air tightness is really a planning task. I know lots of contractors think of it as an implementation detail. You know, it's all about the implementation. From my perspective, it's all about the planning. You know, what I strive for, what I never want on my jobs is for a contractor to be standing on a job site thinking to themselves, I wonder how I should make this airtight. If that should not be a thing that have to happen on a job. It should all be planned out, and it should be, as much as possible, it should be sorted ahead of time. And one of the things that we find, and I know many of you have heard me say this when I teach these types of classes, you know, as you're planning out these airtightness details, if you're confused about how a detail is going to work when you're sitting in your air-conditioned office looking at a piece of paper, you can be certain that the poor contractor who's standing in the rain on a ladder or 10 stories up on scaffolding is also going to be confused. So I think it's really on us as the design and engineering side to try as hard as we can to sort out to make sure that we have the proper product specification, that we've thought through details as far as we possibly can, understanding, of course, that it's a back and forth with the contractor. To that end, one of the things that we are experimenting with that I am quite happy with nowadays is that rather than, as we still do, and as we of course used to do, send around things like PDF drawings or sort of drawing sets, what we've done lately, which I think has been not perfect, but has been more effective, certainly, has been to shift a lot of our information delivery online. Meaning that when we communicate things like specification information, drawings, details, proposed details, the way we're doing it now is by putting it all on a project-specific website, which can then be easily accessed by anybody on the team. It gives us a more centralized location to find that information. And it also allows us to communicate just a lot more information. We can put things like links to specific products right in the text of our recommendations there in ways that we couldn't when we were working with sort of more, flat 2D PDF drawings and the like. So we're experimenting both with lots of different methods of representation, but also different methods of delivering that information to the person who needs it. You know, that's what it's all about, right? Is getting the right information to the right person at the right time. So that they can make good decisions, make better buildings. So we've been experimenting a lot with that type of technique. Go to the next slide, please. But of course, that doesn't mean that we don't spend a ton of time on site as well. So that's all well and good, and drawings are fun, and it's great to make models, and it's awesome to make web pages, and that's all super nifty. But in the end, of course, you still have to spend a lot of time on the job site, standing on the job site, looking at things and figuring things out, sitting around a table with a bunch of people who are actually building it. There's no substitution for that, and so we do end up spending an awful lot of time on job sites working out things. In particular, with renovations, renovations are very tricky because there's a lot of unknowns, and there's a lot of surprises. You think you know how that wall was made, but then as soon as you take the gypsum board off the wall, you realize that it's all made of gummy bears or something, right? There's all sorts of weird surprises that we find in these job sites that require us to sort of think on our feet and make decisions while we're standing there on job sites. So we do spend an awful lot of time on the site with interacting with the contractor teams. If you go to the next slide, please. And of course, we try and make sure that we're recording all of that information. Again, a lot of our job comes down to information management and both recording and thinking about the project, but then also recording those decisions and then communicating those to everyone on the team. And again, I have found personally that the sketches are very effective, especially with the implementation team. I think that we as an industry, architects and engineers need to do a much better job with our drawings. We work as consultants for other architects, other engineers. We see a lot of drawings come across our desk. I think the architectural discipline as a whole has become really lazy with our drawings. I think a lot of them are terrible. And I'm sure that you see a lot of terrible drawings too. And I think we need to work much harder to make better drawings and make better representations so that we communicate information better. And so we try, we don't always succeed, but we try real hard to do that for sure. Can you go to the last slide, Mike, the next one? And so just lastly here, and we do have a few minutes for questions, of course, just lastly, the one last piece that I want to note here is, this isn't like a solution, but I want to just say that I think one of the issues that we're seeing with these buildings, and this is not particular to Passivhaus, it's not particular to renovations, it's sort of industry-wide, but one of the issues that we see commonly is that regulatory agencies, whether they're the Department of Buildings, whether it's Passivhaus certifiers, whether it's somebody giving us incentive money, whether it's an owner, those folks think that we are doing a design, bid, build model of project delivery. But especially when it comes to retrofits, and even more so when it comes to Passivhouses, we're not. It's not really how we're delivering these buildings. In fact, the way that we're delivering these buildings is much more fluid and much more like the diagram on the bottom. And that leads to a lot of headaches when it comes to those compliance pathways or requirements, things like filing a drawing set, getting Passivhaus certification, securing funding. There's a mismatch between how those folks think we're delivering projects and how we're actually delivering projects out in the field. And again, I don't have a solution to that, but I just wanted to flag that as something that we are observing within the industry. We in reality see a process which looks much more like the process on the bottom and a lot less like the process on the top there. And that has definitely brought some issues up in many projects, and it's something I think as an industry we need to sort of wrestle with for sure. So that is all I had to share. Hopefully that was of interest, and of course I'd be more than happy to stick on with Mike, and we'll answer any questions or love to hear any thoughts that folks have about any of that. Thank you for presenting all that, Mike. I appreciate it.
My pleasure.
Sorry about my video, everyone.
No worries. It was a fantastic presentation. Thanks to Michael and Ed for the presentation. Like always, very detailed and very interesting. And so we dive into some of the questions. There was one question regarding that Hvac liquid applied air seal material. What is that? Can you specify a little bit more?
Yeah, I mean, right now we're using, I think there are 4 liquid applied air sealing companies that we've been using. Well, one we're not using that much of, but one is the 2 black ones. You've got Proclima, who now sells that in white as well, which is much easier to see. And then you've got Partel, which is the blower-proof stuff. I think you can also get that in white now. And so then we use a lot of Stowe. Stowe Golds. We've been using that, and we have some contractors who love that. And we've had people mix it because a lot of people like the Stowe Rapid Seal around the joist, no matter what other liquid applied. And then you've got Purple Passive, which we haven't used a lot. I think they're all kind of very similar materials. I don't know if Kevin's on or if Ed, I missed any, but feel free to chime in.
And there's a question regarding the induction cooktops. If you have any feedback from your clients, since the perception of gas for cooking as being the chef's standard is hard to battle. Is there?
Yeah, so I live in a passive house that's all electric, and I can tell you that my wife, it was it was a leap of faith to go from gas to induction because she cooks all the time. I eat all the time and I clean, but I don't cook and or not well. And she loves it. She does. And we've had that same experience mentioned time and time again with people who have it. There are 1 or 2 things that they don't do as well. There are a lot of things they do better, but especially if you have a gas grill for the 1 or 2 items that you might want to, in your yard, if you have a barbecue, for like the steak or the 1 or 2 things it doesn't do that well. But we've had an overwhelming positive response to it.
Mm-hmm. Yeah, in my experience as well with our clients, it's fairly people like induction also because it's safer for kids. You don't burn yourself.
Yeah, I would also say we have a number of clients in New York City mid-project going from gas to electric, going from gas to induction. We have many more people switching from gas to induction than we have the other way. And we've never had someone who went induction who said, wow, I wish I had gas.
And there's a question, maybe that's for Ed, a question regarding the R values on your brick wall in the old building. So what kind of an R value do you have there? Do you run a woofy analysis to make sure that you don't have moisture problems in that wall?
It's a great question. Certainly one that always comes up. So for most of the types of retrofits that we're working with, these types of townhouse retrofits, we don't have to go too much beyond the code minimum, to be honest with you. Certainly for new walls, if you're doing bulkheads up on the top or you're doing an extension out the back, then we're going to try and get those as insulated as possible. But both for space reasons and in order to make sure that we don't reduce the temperature of the brick wall too far, we're typically sticking with like 3.5 inches, 4.5 inches of insulation in the main building itself. You know, in New York with these townhouse projects, we have the benefit of having, in most cases, warm and heated buildings on both sides of our building, you know, the long party wall sides. And so from a compactness perspective, these buildings are really ideal for Passivhaus. And in particular, we're often certifying our buildings to the Retrofit by component certification, which is a special certification pathway, which has been designed specifically for these types of masonry retrofits to address those exact issues. And so we have found that pathway is particularly well suited to exactly these buildings. But the reality is that we don't have to go too far beyond, you know, basic code minimum R value requirements for most of our projects when it comes to those retrofit walls. So 3.5 to 4 inches. Oh, I was just going to say on the moisture front, that's a whole giant can of worms. There's plenty to say about that. We do plenty of woofy. I don't necessarily trust it. I don't think the results are that useful for making decisions. I think in general, I'm not saying the program is wrong. I'm saying it's all about the material parameters that you input, right? So you have to input the right material parameters if you want to make good decisions there. And the reality with these existing buildings is that the material parameters for things like the existing brick are hugely varied across the building. So how you use simulation tools like that to make good decisions is much more complicated. It's a much more complicated question. And so what we end up doing is just taking a really cautious approach. We try not to get anywhere near critical threshold levels that might necessitate a more careful study through something like a woofy simulation. I have a lot of skepticism about the utility of that particular assessment method in these types of projects. So we use a more careful, kind of careful, cautious, conservative approach, and it probably means we're leaving a little bit of performance on the table, but in the service of durability. So that's our personal opinion on that. Yeah, there's plenty more to say about that subject, though. It's
and just to answer a few of the other questions that are all related to this, and I'm going to start with the fact that yeah, there's an issue with overheating, but there isn't because we know it's there. Passive houses. I love the chart, by the way, Ed, and I was going to interrupt you, but I didn't feel like it when you were presenting. You know, the chart that shows the code minimum with heat being the biggest source, and then it kind of steps down from there. I just feel like it's still not one of the things that we're screaming from the mountains the way we should. Passive houses don't need heat. We're only thinking about cooling. We're only thinking about shading. I mean, I'm sure, Ed, you're thinking about heating a little bit too, but you know, we're heating 2 or 3 weeks at night a year tops. So we're getting these houses, even with the wall, with the code minimum insulation thickness that Ed's describing. These houses are at a point where a lot of our clients aren't needing to heat their homes. So getting the shading right, and you know, this is really pointed at me and other architects like me, you know, who need to get their shading right, regardless of the design decision, to make it right and to specify the windows correctly. One of the great things about these Passivhaus windows is you can specify them so you can kind of turn the sun off to a certain degree. I got a little too overexcited at the beginning of doing Passivhaus that we wouldn't need heat and kind of ignored that to a certain extent. But you really need to think about just cooling. And then in terms of the bricks, you know, these are old bricks. They're going to get moist. They're going to let water in. They're going to let water out. I can't say it enough. If you have a client who's not interested in really taking a look at their front and rear facades and really making sure they're in a good place, I mean, it's not a Passivhaus question. It's a hey, make sure your outside of your walls in good shape question. Even with that, even with the perfect pointing, as someone asked in one of the questions, I mean, these walls do let moisture in, and then it comes back out, and really making sure that you've got that covered, or taking it seriously is important. Ed, did I misspeak at all with any of that?
No, I think that's an important point. And again, we are very fortunate in a lot of these old buildings because they were built with the right type of detailing. That is to say, they have the right type of cornice, they have the right type of window sills. You know, those things were implemented on these old buildings for a reason, in order to move that drainage plane out away from the facade of the building. And so we have the benefit of having good sort of bones for a lot of these buildings. I will say that, that's one of the things we look at when we're first looking at a building is, does it have the right type of drainage detailing to support this type of an intervention? And if the answer is no, if the answer is, it was some, 1950s building without any eaves, overhangs, or drip edges or sills of any sort, and you have water running right down the face of brick, well, you might choose a different implementation on the interior if you have that kind of a really sensitive situation. But a lot of the buildings we're working on with Michael and his team are these more historic style with deep cornices and deep window sills and a lot of protection. They were done that way on purpose in order to protect that brick from the beginning. So that's again really lucky in many cases with the types of buildings, the particular buildings that we're working on.
Interesting, yeah, very good explanation. Also, probably a question for Ed regarding your fantastic Rhino analysis pictures. Is your Rhino, is that model informing your PHP, or is it kind of a separate analysis you do on your buildings? And the other question was, what is your kind of preferred tools you use?
It's all woven together. So it's all woven together. We use that Rhino platform. So Rhinoceros is a 3D modeling application for those of you who aren't familiar. It's a very flexible 3D modeling application. It's similar to Revit, except without all the sort of bloat. It doesn't make nice architectural drawings, I guess is the challenge. But from an information modeling perspective, and as a modeling tool, it's incredibly flexible. And so that model allows us to do basically all of our whole building energy modeling and our thermal comfort assessment, our radiation assessment. All of that is able to be done from essentially a single model inside of that platform. So we're using that to drive everything, and we've built some software to allow us to control and drive the PHPP, the Passivhaus planning package, from within that modeling platform as well. So we've built quite a few custom pieces of software in-house to help us move faster and do a better job of all of this stuff. That's all open source though, so anybody can download that and use that if you're interested. But yes, that's all being driven by that same platform. As far as my favorite tool, I mean, the Rhino is probably the most flexible, the most customizable, the most useful tool. But as I showed, we work across lots of different tool sets. I mean, we use dozens of pieces of software plus hand drawing plus Excel. There's any number of different tools that you have to be facile with. I will say that personally, I write a lot more software these days than I ever imagined. So we do a lot of custom tooling, and we make a lot of our own internal processes to speed things up and make it all faster and more reliable, more consistent. And that's been really important. The ability to do that has been hugely beneficial to our own workflow and our own firm.
Mm-hmm. And we stay tuned. We're going to run a very, very interesting course with PHP to Rhino, and it's going to be quite fantastic. We plan to start that in September. So we're doing a PHP class now to get people ready, and then hopefully in September we'll roll out a class around exactly this, how to use this special Rhino tool. But like I said, it's all open source stuff, so you can download it and use it anytime you want. But we'll do a class around that in the fall. If anyone's interested.
One of the questions that's come up, I think, a few times in the chat that I want to, because I know we're getting close to the end, I want to make sure I bring up is just the role of the general contractor. There was a question of whether general contractors are okay with the kind of the fluid design build, we've worked with we're really lucky to work with a number of, we brought most of the contractors that we used to work with into Passivhaus. So Pijo, M2, Clean Construction, a whole bunch of others, Tefera. We brought all of them into it because they were already great craftsmen. They love the back and forth as long as they're getting paid for it. So I think the key piece there is, a lot of us get excited about it. I know I do on site, where we're realizing, hey, we've got this really crazy condition and we're working it out. And the contractors, what I like about everybody I just mentioned is they're right in there with us, working out that detail. Well, the one thing that we have to do as architects and engineers and so forth is we have to be supportive of them, because it's going to be more expensive to build that thing we just mentioned and that thing we just noticed. There'll be a change order. The client has to know that. And they should know that going in. And, you don't have to be so loud about it. So I think it's an open checkbook, but there has to be some sort of allowance in there for the general contractors so that they can enjoy that fluid approach. Because sometimes what happens is, oh, we're excited about it, and in retrofit land, nothing quite exactly happens the way you thought it's going to happen. But if there's a little bit of allowance in there, so that when the contractor spends an hour figuring it out with you, comes out with this great detail that I take credit for in all these presentations, they can get paid to actually implement the detail, and you'll get a happier contractor. It's essential. None of these projects are good without them, just none of them. And yeah, they've got to have that flexibility.
I think that's such an important point, and I think you're totally right, Mike. I think you and I and the contractors want to work that way. What we've observed is that the pushback comes from both the ownership side and the Passivhaus certification side. So, and we don't work on the compliance side, but I'm sure that the Department of Buildings isn't thrilled about that notion either, right? Like, both from the owner side and from the Passivhaus certifier side, if they have this model where they're like, well, just give us your drawings that document what you're going to do, and then go do it. And somehow we have to explain, well, we kind of know what direction we're heading, but we don't really have the details sorted because we can't until we open the wall up and we kind of tear it apart. And that's a really hard conversation to have. It's been a really hard thing for us to manage from the certification side, because they expect us to know everything going in. And it's been really challenging to figure out how to navigate certification when there's so many unknowns as you work through the project. That's been really hard.
Yeah, I'm realizing Kevin Brendan's on. Kevin, being most of these that I showed were your slide, and I really did take credit for most of them. Did you have anything you want to say or add to all this?
Mike, you did a great job. The photos speak for themselves.
I would say so too. Yeah, it's good to see that you guys work as a team, and I think that also answers a little bit the question regarding design build. It's probably almost always a design build, although it's not structured as contractually as design build. But
yeah, and very often everyone besides the contractor is getting paid for that experience. So for me, making sure, and it's hard for the client because the client doesn't want to get over the head with all this stuff. So just make sure there's a little bit of an allowance there, so you can get into that and have it on the side. And the contractors are going to show you how they spent it, and so that the client's protected as well. But to have it so that the contractor gets to enjoy that without it hurting their wallet is I think, pretty important.
So I would like to thank everyone, Michael and Ed, and also Kevin, for presenting. It was pretty good presentation again. We'll make that recording available for everyone, and we have a couple of more questions in the chat box. I'll send out Michael's and Ed's contact, and you guys can continue answer some of those questions. So thanks everyone for joining, and thanks for presenting.
Very good. Thanks everybody.
Thank you.